Welcome back to The Explainer. Okay, if you're sitting your GCSE EdXL psychology exams, you are in the exact right place. Today, we're diving into a high-yield exam masterclass to completely lock down the topic of sleep and dreams. By the end of this, we're going to have you walking into that exam hall with absolute 100% confidence.
So, I want you to think about the weirdest dream you had last night. You know the one. Did it have some deep, profound, hidden meaning about your life? Or is your brain literally just making things up while you lie there completely paralyzed? Well, that is the core mystery we are going to explore today by looking at a major biological theory of dreaming.
Okay, let's dive into this. Here is our roadmap for today. 1. Sleep basics recap. 2. Activation synthesis theory. 3. The biology of dreaming. 4. Evaluating the theory. And 5. Nailing exam questions. Part 1, Sleep Basics Recap, High-Yield Knowledge. Let's kick things off with a rapid-fire revision round to wake up our brains. These are the foundational facts that constantly pop up in multiple-choice questions. For narcolepsy, spot the symptoms: daytime drowsiness, sleep attacks, cataplexy, and sleep paralysis. Notice the difference in disorders. Primary is the problem itself, while secondary stems from an underlying issue. Also, your sleep cycle, that's an ultradian rhythm, meaning it happens numerous times in 24 hours. And C for sleep-wake cycle range, that sits right between 18 and 51 3/4 hours. Lock those away. Now listen up, because examiners absolutely love to test the difference between these next two terms. Endogenous pacemakers are internal factors regulating your sleep, like the hormone melatonin. Exogenous zeitgebers are external cues from your environment, like sunlight. Remember, endogenous means inside, exogenous means outside. Do not mix those up. Part 2, Activation synthesis theory, the core concept. Back in 1977, Hobson and McCarley proposed an idea that was a total game changer. Listen to this core concept. Dreams aren't meaningful, but are the result of random brain activity during REM sleep. Up until this point, a lot of people believed dreams had these mystical or deep psychological meanings. But Hobson and McCarley came along and offered a radically biological explanation. They essentially said, nope, no hidden messages here, it's just biology and random sparks firing in your brain. Part 3, the biology of dreaming, inside the brain.
Now, what's really interesting is how this actually works. This is where you're going to secure those heavy AO1 knowledge marks. The whole process has a distinct starting line, a part of the brainstem called the pons. During REM sleep, that's rapid eye movement sleep, the pons generates what we call PGO waves. Think of these waves as rapid-fire messages being sent from the brainstem to other parts of the brain, specifically the occipital cortex. But here's the crazy part. While these internal messages are firing away, your body throws on two vital safety mechanisms. First up, sensory blockade. Basically, incoming information from the outside world is totally blocked off. Second, movement inhibition. Your physical movement is temporarily paralyzed. This is incredibly important because it physically stops us from acting out whatever bizarre, wild things are happening in our dreams. You are locked in, relying purely on internal brain activity. So, how do we actually get the dream? Well, think of this as your golden rule of 3. Step 1, the limbic system, located in the temporal lobes, is randomly activated. Step 2, the occipital lobe is randomly activated. And crucially, your brain treats all this random neural firing as if it were real sensory data, which leads us straight to Step 3, brain interpretation, otherwise known as the synthesis.
This synthesis step is fascinating. You see, your brain absolutely hates chaos. When it receives all these random PGO waves, it desperately tries to weave them into a coherent narrative just to make it make sense. To pull this off, it draws on your stored memories, your past experiences, and your thoughts. So, according to the theory, the dream isn't some secret spiritual message. It's literally just your brain trying to narrate a story out of complete biological chaos.
Part 4. Evaluating the theory, strengths and weaknesses.
If you want to hit those top-grade boundaries, you've got to critically evaluate the theory. Let's start with the supporting evidence. And this brilliantly illustrates their point. Hobson and McCarley actually ran tests on cats. They found that the pons and the reticular activating system, the RAS, are indeed highly active during REM sleep. Because they could physically measure this brain activity, it strongly supports the idea that dreaming comes from internal biological factors rather than something magical.
But what about the other side of the argument? A perfect way to structure an evaluation paragraph in your exam is to set up a direct showdown. Put Hobson and McCarley head-to-head with Sigmund Freud.
While our biological theory says dreams are just random activity with zero hidden meaning, Freud proposed the exact opposite. He argued that dreams are deeply meaningful, acting as symbolic expressions of our unconscious desires and repressed thoughts. Dropping this contrast into your answers shows the examiner you really grasp the wider psychological debate. You're also going to need specific opposing evidence against activation synthesis. First off, the theory claims dreams are bizarre purely because the brain waves are random. But get this, research, including a study Hobson himself was involved in, suggests that only about 34% of dreams don't make sense. That means roughly 66% of dreams actually do make logical sense. That completely contradicts the random chaos idea. Secondly, think about lucid dreaming. If dreams are entirely random and totally out of our control, lucid dreaming, where people are actually aware they're dreaming and can control the story, simply shouldn't be possible.
Let's move to part 5 and see how this builds into nailing exam questions, AO1 and AO2.
Okay, let's put this into practice. Read this scenario carefully. Victoria tells her doctor she's not tired at bedtime and mentions she sleeps with the light on. The keywords flashing in your mind right now should be light and its impact on sleep. So how do we structure a perfect 2-mark answer for this? Here's the breakdown. You have to separate your general knowledge from the specific scenario. For your AO1 knowledge mark, state the fact. Light is an external or exogenous Zeitgeber, which triggers the SCN to release melatonin when it gets dark. Boom, 1 mark. But to get the AO2 application mark, you must apply that fact to Victoria. The light Victoria leaves on acts as an external cue, making her brain believe it's still daytime, which stops her from feeling tired. Always link the science directly back to the person in the question. Let's try one more. Sarah dreamt about being a butterfly, feeling like she was flying, and now she thinks it's a sign she needs a holiday. Her friend, however, says dreams are literally just brain processes. Explain one reason supporting her friend. Right, whenever a scenario mentions dreams lacking meaning, that is your immediate cue to use the activation synthesis theory.
So the crucial point here, and this is a massive exam hack, is how you format your answer. AO1, state that the activation synthesis theory suggests neuroactivity during REM sleep is random. AO2, explain that Sarah's dream of flying is just her brain processing this random activity, not a meaningful sign to book a holiday. And here is the hack. Literally underline your AO2 application in your answer booklet. It forces you to make sure you've actually applied the knowledge and guarantees the examiner sees it. We have covered a massive amount of ground today, from the pawns firing off PGO waves to the brain synthesizing a story, all the way to evaluating Hobson and McCarley against Freud. But before you go, I have a provocative revision challenge for you. Can you summarize the activation synthesis theory out loud right now in exactly 30 words? Try it. Test yourself. Lock this knowledge in, and best of luck with your revision. See you on the next explainer.